which include, but are not limited to, strings, lists, tuples, sets, or dictionaries. And well, everybody, those are membership operators in Python. Hey, what's going on, everybody? So in today's video, I gotta explain list comprehensions in Python. A list comprehension is a concise way to create lists in Python. They're compact and easier to read than traditional loops. Basically, you have to follow this formula. For every value in something that's iterable, meaning you can loop through it, check some condition, then do this expression. So let me give you an example with using a traditional loop. Then you'll be able to see why a list comprehension is useful. We're going to create a list and double the numbers 1 through 10. Doubles equals an empty list. Using a traditional for loop, we will say for every value, let's say x, in range 1 through 11. Remember that in the range function, the second number is exclusive. This will give you the numbers 1 through 10. For the first iteration, x is going to be 1, then 2, 3, all the way up until 10. So we'll iterate 10 times. During each iteration, I'm going to take my list of doubles, use the built-in append method. We will append x during each iteration. That's going to be the value times 2. So if I were to print my list of doubles, here's the result. We have the numbers 1 through 10 all doubled. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So this is a lot to write. We can use a list comprehension to make this code more compact and easier to read. Here's how. We need a name for this list. Let's say doubles equals an empty list. Within our list, we'll follow this formula. We have an expression for value in iterable, and optionally, we can check a condition. We'll do this in exercises later on in this topic. We'll begin with for every value, let's say x. In our iterable is going to be a range 1 through 10. Again, for the first iteration, x will be 1, then the second iteration, x will be 2, all the way up until 10. During each iteration, what would we like to do with x, our value? Let's take x, multiply it by 2, and return it. Then, if I was to print my list of doubles, we have the numbers 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. For every value in this iterable, do this. Multiply it by 2. This is a list comprehension. It's a concise way to create lists in Python. We'll go over a few exercises. So this time, we will triple each number. We'll create a list of triples equals, let's say this time for every y in range 1 through 10, so we have to write 11, take y and multiply it by 3. Then we will print our list of triples. 3, 6, 9, 12, 15, 18, so on and so forth. Let's square each number. We'll create a list of squares for every z in range 1 through 10. To square a number, we take that number, multiply it by itself. So the numbers 1 through 10 squared is 1, 4, 9, 16, 15, 36, 49, 64, 81, 100. So 10 times 10 is 100. Now we're going to work with strings. We'll create a list of fruits equals, think of some fruit. These are all going to be strings. Apple, orange, banana, coconut. I'm going to take each string in this list and make it uppercase. We could assign this to a new list, such as uppercase fruits, or we can simply just reassign it. Just to keep it simple, I'll reassign it. So again, we're following this formula. I like to begin with the for value in iterable portion. For every fruit in our iterable of fruits, what do we want to do? Well, let's take each fruit, use the built-in upper method to make it uppercase. Then I'm going to print my list of fruits. Each string in this list is now all uppercase. You could even cut down on one of the steps. With our iterable of fruits, I will place this list. And this does work too, although I do find this a little more difficult to read, but you can take either option. How about instead of making each string uppercase, we'll take the first letter of each string, then put it within a new list. So let's take each fruit at index of 0, that will give us the first letter. We'll place it within a new list of fruit chars, meaning characters. Here's the result. A, O, B, C. For every fruit in our list of fruits, return the first character of each string. A, O, B, C. Now we'll work with conditions. We'll create a list of numbers, both negative and positive. Numbers equals, let's say 1, -2, 3, -4, 5, -6. We'll create a list comprehension to create a new list where all of the numbers are positive. Our new list will be positive nums. Equals, we'll write a list comprehension for every, let's say, num in numbers, we'll write a condition. Return this number if our num is greater than or equal to 0. We do need an expression. If we're not modifying each value, we can just return the value of num. During this exercise, we're more focused on the if condition rather than the expression. If our value of num meets this condition, simply return it and place it within this new list. Let's print our list of positive numbers. And we have 1, 3, 5. Let's do this with negative numbers. I'll just copy what we have and change a few things around. This list will be negative numbers. Negative nums. For every num in numbers, check this condition. Check to see if num is less than 0. If so, return that number. Let's print our list of negative numbers. -2, -4, -6. Let's check to see if there's any even numbers. Even nums equals, for every num in numbers, check to see if our num is divisible by 2. And we can do that with the modulus operator, followed by 2. The modulus operator will give you the remainder of any division. If our number is even, number modulus 2 will equal 0. If it's even, this is going to equal 0. If it's odd, it's going to be 1. We're not modifying our value, we're just going to return our number. Our list of even numbers should be -2, -4, -6. Let me add one more value. Let's add +8. -2, -4, -6, +8. Maybe we'll add one more. -7. Okay, let's find any odd numbers. Let's copy this line of code. Replace even numbers with odd numbers. If num modulus 2 is equal to 1, that means that number doesn't divide by 2 evenly. Then we'll print our odd numbers. 1, 3, 5, -7. All these numbers are odd. Here's the last exercise. We'll create a list of grades. We'll create a new list of any grades that are considered passing, meaning they scored 60 or above. So let's say one student has a grade 5, 7. All these numbers are odd. Here's the last exercise. we'll create a list of grades. We'll create a new list of any grades that are considered passing, meaning they scored 60 or above. So let's say one student has a grade of 85, another with the 42, 79, 90, 56, 61, let's say 30. I will create a new list of passing grades equals, again, follow this formula, for every grade in grades, check our condition. If our grade is greater than or equal to 60, we will return the current grade. Then let's print our list of passing grades. And that will give us 85, 79, 90, and 61. All of these grades are greater than or equal to 60. All right, everybody, so that is a list comprehension. It's a concise way to create lists in Python. They're compact and easier to read than traditional loops. Remember, for every value in your iterable, optionally, you can check a condition. You can write an expression to modify that value if you choose, and return something. All right, everybody, so those are list comprehensions in Python. Hey everybody, so today I'm going to explain match case statements in Python. If you're familiar with other programming languages, this is also known as a switch. Match case statements are alternatives to using many, also known as a switch in Python. Hey everybody, so today I'm going to explain match case statements in Python. If you're familiar with other programming languages, this is also known as a switch. Match case statements are alternatives to using many else if statements. We execute some code if a value matches a case. The benefits of using a match case statement is that they're cleaner and the syntax is more readable. In this sample program, I have a function. There is one parameter, a day. Day will be a number, ideally a number 1 through 7. Depending on this number, comprehensions in Python. Hey everybody. We'll return a string corresponding to the day of the week. If day equals 1, then it is Sunday. 2, it is Monday, all the way up to 7, where it will be Saturday. I do have an else clause if we pass in something that's not valid, like pizza. Pizza is not a day, but it really should be. Not a valid day. A cleaner and more readable alternative is to use a match case statement instead of many else if statements. Here's how. I'm going to take my if and many else if statements and enclose them within a match case. Match case. The case is going to be the value we're examining. The case will be day. Colon. We're going to examine our value of day against matching cases. We're going to replace if day equals with the following, just simply case. So let's do that with each of these statements. If you have an else clause, you're instead going to have a case of underscore. An underscore in a match case statement is a wildcard. We will perform this case if there are no matching cases. This case would function as the else statement. Here's what we're working with now. If I pass in 1 and return the day of the week, we would get Sunday. 2 would be Monday. 3, Tuesday. 7 is Saturday. And then let's try that day of pizza. That is not a valid day. A match case statement is an alternative to using many else if statements. I find this much easier to read than the many else if statement. To use that is not a valid. And then let's try that day of pizza. That is not a valid day. A match case statement is an alternative to using many else if statements. I find this much easier to read than the many else if statements. Both would technically function. Let's go over a second example. We will create a function of is weekend. We have to pass in a day. This time our day is going to be a string, such as Monday. The value for each case, instead of a number, is going to be a string. If our day matches a case of Sunday, let's return, how about a Boolean of true? We're checking to see if it's the weekend. If our day is equal to a case of Monday, then we will return false. Let's do this with the other days. I'm going to fast forward the video. And our day is equal to a case of Monday, then we will return false. Let's do this with the other days. I'm going to out a Boolean case instead of a number is going to be a string. If our day matches a case of Sunday, let's return, how about a Boolean of true? We're checking to see if it's the weekend. If our day is equal to a case of Monday, then we will return false. Let's do this with the other days. I'm going to fast forward the video. We will call the function of isWeekend, then pass in a day of the week, such as Monday. So is Sunday the weekend? That is true. Monday? That is false. Saturday? That is true. And we do have a wildcard case if there are no matches. Is pizza a day of the weekend? That is false. There is a way we can modify this match case too. We tend to be repeating ourselves a lot. The days Monday through Friday all return false. We're going to use the OR logical operator, which is represented with a vertical bar. If the case of Saturday or Sunday return true, if the case is Monday or Tuesday, we can get rid of that, or Wednesday, or Thursday, or Friday, then we will return false. We can keep our wildcard case. So, is Saturday part of the weekend? That is true. Is Monday? False. Sunday, true, Friday, false, and pizza. We have our wildcard case. That gives us false. Alright everybody, so those are match case statements. They're similar to switches in other programming languages. They're an alternative to using many else if statements. We execute some code if a value matches a case. The benefits is that the code is cleaner and the syntax is more readable. And well everybody, those are match case statements in Python. Hello friends, it's me again. Today I'm going to explain modules. A module is just a Python file containing code you want to include in your program. You use the import keyword to include a module. You can use built-in modules or create your own. Sometimes it's useful to break up a large program into reusable separate files. For a list of all the modules found within the standard Python library, you can use the help function, pass in the word modules, and then we would need to print this. Here are many of the different modules available to you. A few you may recognize would be math, string, time. One of my favorite names of a module is the pickle module. Unfortunately, it doesn't have anything to do with pickles. It's used for serialization. To list all of the different variables and functions found within a module, you can place that name of the module within the help function. For example, with the math module, here are a few different variables we would have access to, and a few different functions. To include a module, we would type import the name of the module, for example, math. I now have access to everything found within the math module, including those variables and functions. To access those variables and functions, I would normally type the name of the module dot the name of the variable or function, such as pi. Then let's print this. Pi from the math module is 3.14 and some change. Another way to import is to type import the name of the module as, you can give your module a nickname, an alias, whatever you think of, such as M. M short for math. We would no longer refer to this module as math. We would refer to it as our alias, M. Using an alias would reduce some of the typing you have to use if you have a very long module name. Another way to import is to use from the name of the module, import something specific. Pi, for instance. You would no longer need the module name. From math import pi, pi would be included within our namespace. However, I tend to not use from import as much, just because it's possible there could be name conflicts. Here's an example. Let's say from math import e. E is an exponential constant. E is 2.71. What if I was to create a program where we have 4 variables named A, B, C, D? A equals 1, B equals 2, C equals 3, D equals 4. Then I'm going to print E from the math module to the power of A. That would give me 2.71. Then let's do this with B, C, and D. E to the power of B, E to the power of C, E to the power of D. Here are the results. Let's say we have a different variable, E. E will be 5. Then I will print E to the power of E. We have imported E from the math module. When we have declared all of these variables, technically what we've done is we have created another version of E. We will end up using the second version rather than the version that we have imported from the math module. All my results are now different, and it's possible you may not realize it. I like to be more explicit. I'm going to import math. If I'm using a variable or function from a module, I much prefer to prefix that variable name or function with the name of the module in which it's from. Math.e to the power of A, to the power of B, to the power of C, to the power of D. Math.e to the power of our variable E. And these results are to be expected. Now, to create a module, what we're going to do is right-click on our project folder, go to New, Python file, think of a module name. maybe example. Then click Python file. We now have two tabs, main and example. Declare whatever you would like within this module. Let's create our own variable pi. Pi equals 3.14159, then a few functions. Let's create a function to square an argument that's passed in. Define square. We will accept an argument which we will name x, then return x to the power of 2. Let's define a cube function. We will accept one argument, then return x to the power of 3. Maybe a circumference function. Define circumference. We will accept a radius, then return 2 times pi times radius. Then an area function to calculate the area of a circle. We will accept a radius as an argument, then return pi times radius to the power of 2. All right, here is our example module. Within our main Python program, let's import the name of our module, which we named example. We now have access to everything within this module. I'm going to declare a variable result and set it to the name of my module, dot pi. Then I will print the result, which is 3.14159. Let's utilize the square function. Result equals example dot square. Let's square 3, which is 9. Let's use the cube function. That would be 27. Circumference. That circumference within this module of our module, which we named example. We now have access to everything within this module. I'm going to declare a variable result and set it to the name of my module, dot pi. Then I will print the result, which is 3.14159. Let's utilize the square function. Result equals example dot square. Let's square 3, which is 9. Let's use the cube function. That would be 27. Circumference. That would give me 18.8. Then area. That would be 28.2. That's how to create your own module. It can be useful at times to separate your program into individual files. Alright everybody, in conclusion, a module is just a file containing code you want to include in your program. You use import to include a module. You can use built-in modules or create your own. If you do need a list of the modules available to you, again, you can use the help function, then pass in the word modules. And well everybody, that's how to get started with modules in Python. Hey friends, it's me again. Today